Hey there, this is Randy. Today we're going to talk about how to convert from exponential expressions to radical expressions, and also from radical expressions to exponential expressions. Let's go. So let's start with a really simple example. So we need to try to write the square root of x as an exponential expression. Well, do you remember how if we have some number, let's say 5, this is actually the same as saying 5 to the power of 1, but we don't write that 1. So just like the 1 on this 5 is implied, the 2 right here in the square root is also implied. So now that we understand where are those implied numbers, that is the 2 and the 1, let's try to write an expression that is exponential instead of a radical. Well, it's going to be x to the power of some fraction. But how do we know what is that fraction? Well, the numerator of the fraction will be this number that is the exponent on the term inside the square root, and the 2 will be the denominator. So the square root of x is x to the power of 1/2. So the 1 went into the numerator and the 2 went into the denominator. Now what about the 5th root of x? Well, same logic. This x has an exponent of 1. So this 1 right here will be the numerator and this 5 will be the denominator. So this radical expression, that is the 5th root of x, can be rewritten as x to the power of 1/5. So in this third example, we have the 5th root of x cubed. So in this case, the numerator in our exponential expression is going to be the 3 instead of 1, and the denominator, again, is going to be 5. So now we have x to the power of 3/5, or x to the power of 3 over 5. All right, now what about this last example? It's a little bit more complicated. So spoiler alert, this expression right here, the 5th root of x cubed, is the same as this last expression. Let's talk about why. So first of all, let's just write this inside part, inside the parentheses, as an exponential expression to the power of 3, right? Because there's a 3 right here. And then we'll simplify even more from there. So we know that this x, just like in previous examples, like in the first example and the second example, had an exponent of 1. So there's a 1 right there. So this entire expression inside the parentheses would be x to the power of 1 over 5. So there it is, x to the power of 1 over 5, or x to the power of 1/5, all raised to the power of 3. Okay, now what do we do? According to the properties of exponents that you should have learned in Algebra 1, when we have a power, such as x to the power of 1/5, raised to another power, what do we do with those exponents? We multiply them. So this is the same as saying x to the power of 1/5 times 3, or we can say 3 over 1. So now we just simplify the exponent and we're done. So we're going to multiply across. So 1 times 3 over 5 times 1. So 3 times 1 gives us the 3, and 5 times 1 gives us the 5. So although you may not have expected it, when we have the exponent being applied to the variable inside the radical, or if we apply that same exponent to the entire radical expression, we still get the same exponential expression. In this case, x to the power of 3 over 5. All right, now let's go the other direction. Convert the following exponential expressions to radical expressions. So what would be the exponential expression m to the 1/2 converted to a radical expression? Well, first of all, let's just write the m again. All right, there's our m. Now let's write the radical. Now we know that the numerator of the fraction that is the exponent will become the exponent on the term inside the radical, and the denominator, in this case the 2, will go in front of the radical. So technically, this is the square root, so we could write a 2 right there, of m to the power of 1. So there's a little 1 as the exponent right there. But when we have an exponent of 1 and we have a 2 right here in front of the radical, we typically don't write those numbers. So m to the 1/2 is the square root of m. What about c to the power of 1/8? The logic is exactly the same. So much like in the previous example, this numerator, this 1, will become the exponent on the variable inside the radical, and this 8 tells us that it's going to be the 8th root of c. And again, because this exponent is a 1, we don't really need to write the 1, and it's more typical to not write that 1, because it's already implied. Now we need to keep in mind that this expression right here is not 8 times the square root of c. It's not that. This is the 8th root of c. Now if I want to write 8 times the square root of c, that would be like this. You can see that 8 is bigger, but this time we have the 8th root of c with a little 8. Alright, so there it is, the 8th root of c. Alright, last example. Let's convert k to the power of 5/4 to a radical expression. So our numerator in the exponential expression became the exponent on our variable inside the radical, and our denominator became the 4 in front of the radical. Now it would also be equivalent to write the expression with 5 as the exponent being applied to the entire radical expression. Alright, so now let's talk about some specific terminology before we finish. So the number that we have in front of the radical symbol, like in this case we have 4, in this case up here we had an 8, and in this case we have an implied 2, that number is what we call the index. And the number that we have inside the radical, whether it be a number by itself or a number with an exponent, that entire term is what we call the radicand. Now keep in mind that 5 by itself is not the radicand. The radicand is k to the power of 5, that entire expression. Just like in this case above, c is the radicand, and in this case above that, m is the radicand. And now that we know how to convert from exponential expressions to radical expressions and radical expressions to exponential expressions, we are finished. See you next time.